slide.
You're gonna fill up all the pages.
Well, yeah. I'm
Okay.
gonna rip this out and do.
So yesterday we did law of cosines. Today we're going to do law of sines. It kind of works in the same way. It's still used to solve non-right triangles. However, today we're working with a different set of equations. This should also be reviewed from geometry. So law of sines says given any non-right triangle, so for example this one, where my angles are A, B, and C, and my sides are also little a, little b, and little c, then the proportionality of the angles and the sides should be equal for each set. So law of sine says that sine of angle A over side A is going to be equal to sine of angle B over side B, which is also equal to sine of angle C over side C. The inverse is also true. So little side A over sine of angle A is equal to side B over sine of angle B, which is equal to side C over sine of angle C. So either one of those sets is what you can use as long as you keep it consistent throughout the whole problem. So we can't be switching back and forth for different parts. Either we do all of them with the angle on top or all of them with the side on top. Law of sines are used to solve angle, side, triangles, and angle, side, angle, triangles, and also some side, angle triangles. Yeah, but not all of them, only some of them.
I walked in like the class yesterday. What does it matter which one's which?
What do you mean?
Like, why does it matter if it's an angle side or side?
Well, this will just help you indicate whether you can use law of cosine model or law of sines, because I'm not going to tell you which one to use. Yeah. So we're going to jump right into an example, because I think that's the best way to practice this.
That's the whole. Wait, what's?
That's the whole equation we're going to use. Is these one of these? That's it.
Oh,
That's all we're
so much
using.
better.
The entire homework.
The entire homework. That's all we're using. Example 1.
I'm not fogged.
Solve triangle A, B, and C.
No.
Oh, that's. If angle A is equal to 48 degrees, angle C is equal to 57 degrees, and side B is equal to 47.
The F was looking like my age is not like an H.
So of course I go ahead and draw a triangle first. And I label my sides. And then I fill in the information I have here. Based on the drawing, what type of triangle is this one? Angle, side, angle, which reaffirms that I can use law of sines to solve this one because we said that this is used for angle, side, angle triangles. In order to use law of sines, however, I must have one complete angle side pair. Right now, I don't, because I have angle A but not side A. I have angle C but not side C, and I have side B but not angle B. How can I fix that? Solve for angle B. How do I do that, Becca?
180.
Awesome. So I need to solve for angle B. That way I have one complete angle side pair, and then I can use the angle side pair to solve for the other two missing sides. So the first thing we're going to do, as Becca said, is solve for angle B. And that is going to be 180 minus the two angles that I know about. So when we do the subtraction, what do we get angle B to equal? 75. So now I know that angle B is 75, which means I have one complete angle side pair. So that's what I'm going to write first before I decide what I'm solving for. So my complete angle side pair is B, which means I have sine of 75 degrees over side B, which is 47. And this is going to be equal to another angle side pair with the missing piece still there. So do we want to solve for A or C first? Okay, it doesn't matter. It's up to you. But our fraction has to be written in the same way that the first fraction is written. So angle on top, side on the bottom. So for A, I know that angle A is 48 degrees, but I don't know what side A is, so I'm going to leave that as the unknown little a. And now the whole thing I have to do to solve this is just get A by itself, and then I can plug it into my calculator. So how are we going to get A by itself?
You multiply it over.
Right, I'm going to cross multiply to move this denominator up and move this denominator up. When I do, I get A times sine of 75 degrees equals 47 times sine of 48 degrees. And then again, my goal is to get A by itself. So what else do I have to move?
Sine 75.
How am I going to move it, Ismail?
Dividing.
By dividing it. So then what I plug into my calculator is 47 times sine of 48 divided by sine of 75. And my answer will be the length of side A. What mode should our calculator be in? Degree, awesome. Also, we're probably just going to round to the nearest whole number for these sides.
I knew there was something fishy about that being
What do you mean? This is easy.
a lot of steps to screw
Has
up.
to complain at least once.
I don't want to hear it. You all complain more than me.
Colin reports are accurate.
Basically,
I might.
claims there, Colin.
Oh my god.
Pretty funny.
A lot of talking coming from someone who doesn't have possession of the marble.
I don't want to talk about yesterday, Gabe. I'll take the marbles back. Just give me a day.
Okay, so what do we get for side A?
36.
36. We don't have units, so we just leave it as 36. And now what do I need to solve for? Side C, I'm going to do the same thing. I always like to keep using the same original complete pair. So I, again, would start with sine 75 over 47. However, if you wanted to now, since we know both parts of A, you could also use A as your complete pair to base ratio C off of. It is entirely your choice. I like to keep my originals the same. So setting up for C, I would still use sine of 75 over 47 equals, I know angle C is 57, so be sine of 57 over unknown side C. And I'll do the same thing I did before, cross multiply, isolate the C, and then plug it into my calculator. What are we getting for side C?
41.
41. And just like yesterday, I like all of your answers in one central location, boxed in. It was easy for me to read them. And then we move on to the next example. I'll give you guys a second to finish writing. We have 3 more examples that we're going to do today. What? 3.
I can't count that high.
Not surprised, Gabe.
Any major questions, concerns, or issues so far with law of sines? Who likes this one better than law of cosines?
See,
I
I
wouldn't
couldn't
give it
even,
to
the same.
couldn't
That's the same for you.
couldn't even do it, so.
Let's do a lot of tangents.
I like law of sines better, which is why I teach it second, because you guys tend to think it's easier.
That's just easy to remember.
Oh yeah, much easier to remember. Although once you see the pattern happening in law of cosines, it's really easy to remember those two. Okay, next example. Yeah? Awesome.
You act like I can say no.
Yeah,
I'm
I
upset
know.
with you.
That's the beauty of it.
He likes to make you feel like you have an option.
So go ahead, say no, so I can just keep going.
Alright.
So this time we're solving triangle A, B, and C. If angle A is 67 degrees, side A is 100, and side C is 125. It might also help to draw the picture, although you don't necessarily have to, but I always suggest it.
Ooh, it's
Just like you gave.
Okay, Marissa, what did you notice? We have A. We have a complete pair for A. We know the angle and we know the side. What issue do we already see arising though? What don't I know?
Any of the.
Any of B. So I'm gonna have to find a way to solve for one half of B. That way I can use law of sines to solve for the other half. So which part of B is gonna be the easiest to solve for? The angle, but I have to solve for angle C before I can use subtraction to solve for angle B. So I have to use law of sines to solve for angle C first. I'm glad you guys saw that. So of course I'm gonna use my complete pair for A, and then I'm gonna use the part that I know for C, and we'll solve for the unknown. So setting up my law of sines, I have sine of 67 degrees over 100 is equal to sine of angle C over side C, which is 125. I have to isolate the whole sine of C part of this. So what's the only thing I need to move?
The 125.
The 125. How do I move it, Colin?
There's multiply.
Multiply it over into the top on the left, which leaves me with sine of C equals 125 times sine of 67 over 100. I go ahead and I plug that into my calculator and I get a decimal, and then we'll do inverse to solve for the angle. Okay, what decimal do we get? Something above 5. Oh, not 5, 1. So you should end up with the decimal 1.15. We know from our unit circle that sine is never greater than 1 or less than -1. So I automatically know before I even plug it in that this is going to give me domain error, which means that this triangle is not solvable because it can't theoretically exist. So you saw this happen on number 11 on your homework yesterday. It happens. Just because they think that this triangle can exist with these given sides and angles doesn't mean in actuality that it can. So if it can't, we just put no solution or not solvable triangle. So once you got this, and try to do the inverse, yeah, we would get doesn't exist, which means this is no solution. Once you get that to happen on one piece, the triangle is finished, because we can't have one piece not existing. Yeah, just no solution or not solvable.
Triangle sucks, not my fault.
You know, that would be acceptable as well.
If some of you don't write that down,
I wrote it down on my notes.
Okay, any questions on that? It's okay if you don't recognize that from the decimal. When you go to do the inverse, it will be apparent that it's not going to work. Any questions on that? Okay, 2 examples left.
do you think this is gonna take up a lot of space? Like 9 lines.
Line. I'm gonna let you guys do this one on your own. And then we'll come together and work through it. So I would like to solve triangle ABC given this information.
I still want to surround it the nearest whole number.
On this one, let's go to the nearest tenth, since that's what the measurements I've given you are rounded to.
I do believe the reverse cosine, or whatever it's called, right?
Reverse?
Reverse.
Inverse sine.
Yeah, that's what I meant. Yeah.
I think we'll look at the last example, 6 lines.
There could be 6 lines to write it, like just the word.
So you're telling me I can condense my last 2 problems just for
Well, I guess let me see how much you condense it. I can gauge.
I got this much. I did the last problem in 2 lines,
Oh,
3 lines.
thanks. You might be able to, depending how like
You
small
can
you
just like
write.
write out the words on there and then next page do the problem.
Yeah, I was not right.
We should make like pop-up math books where it's just the words written out, and then we do like a pop-up that has the actual problem.
That sounds.
That sounds kind of fun.
Wait, what? So the words on the book.
Yeah, like the words on the book, and then you just have like a flap that you open to see the problem.
Oh,
Like an
I think it
interactive
pop up,
math
like,
book.
it like it
Like,
pops up at you.
That would be fun, but I don't know how we would like engineer that. So they wouldn't flatten over time. Are we getting it to work out? I know it's kind of new and it takes a little bit of time, so I'm trying not to rush any of you. But all of my work is on the board if you want to check it.
That's your daughter's first book ever. It's gonna be a pop-up math book.
She already has ABCs and math. I mean, what more does she need?
After this is done.
We do have quantum physics for like quantum physics for babies, and we read that one.
Oh my gosh.
Yeah.
Not even
I think we have an engineering book at home too. like for babies.
She's like, ooh, I made this break. No, you sold it.
I did let her pick like her bedtime story last night, and I gave her the complete works of Shakespeare or ABCs of math, and she picked ABCs of math.
Fire.
So
How did she pick?
she crawled through it. So I put them like
Probably because she's
out.
like, this will make me fall asleep faster.
maybe it was whatever works.
Because she's so interested in Shakespeare already.
Here's my beat.
Which I try to do like classics. 'Cause
Yeah.
I like the classics, so I
Does she sleep through the night?
Probably because she's scared I'm also reading math to her again. I ain't good enough.
It's like, yeah.
I don't think I've ever met anyone who would read the complete works of Shakespeare to their baby.
We have the complete works of Jane Austen. We have Shakespeare. We have the Bronte sisters. We've got we have Emma.
Is that
I have a bunch.
I just find that slightly entertaining.
I don't care anything about
I mean, like we have other books too. I don't just subject her to the classics, but or math. But those are
This
the
or
ones
nothing.
I'm raising her
Yeah,
to be
you're right,
very
I don't-
cultured.
I'm trying.
Yeah, I don't care any biology in there.
No.
No?
No.
Oh, wow. That's
Find a good biology book for babies, and we'll talk. Okay. Any questions on this
the
example?
very hungry caterpillars?
That's a true classic.
Yeah.
We have that
How
one.
did you name that off the top of his head?
I don't know, and I'm
Because that's the best biology book there ever
I'm
is.
so glad I'm recording this.
Good. Yeah, you should. Send this to IU.
Okay, are there any questions over this particular example? Did anybody not get it to work out? Anybody have any issues with it?
I still don't.
Okay, we're gonna do an applications problem, which means word problems. Yeah, I'm excited. Angle C, I got 84.9.
Whoa.
Little C, I got 14.5. Okay, I'll come back and look at it in a minute. Let me write this next problem though. Oh,
Can you also look at mine?
yes, I will.
I was just trying to finish. Didn't really get mine.
So this problem says, when the angle of elevation of the sun is 64 degrees, a telephone pole that is tilted at an angle of 9 degrees away from the sun casts a shadow 21 feet long on level ground. Use this to approximate the length or height of the pole. This is the last example we're going to do. So when we're presented with a problem like this, what is the first thing that we need to do? Draw a picture. That usually gives us more information than just the story problem itself does. So on this picture, I'm gonna start with the sun because that's the first thing that it told me. So I have a sun. I also have a pole, correct? And this pole, it tells me, is tilted 9 degrees away from the sun. So if the sun were going straight down, there's a 9-degree tilt left of the pole. I also know with the sun shining on this pole, the pole is creating a shadow that is 21 feet long that extends away from it on level ground. So this is going to be my shadow here, and I know that it's 21 feet long. I also know that the angle of inclination from here to the sun is 64 degrees.
Can't see.
It asks me then to approximate or estimate the length of the pole. I know that my pole here, I'm going to label as, let's say X, because I don't really know. In order to solve for X, I know I'm using law of sines because that's a lesson that you're in. So I know I'm going to be using it paired with the angle of 64 degrees. In order to use law of sines, what else do I have to have in my problem? Say that again, Marissa. I have to have a complete set, right? Which means I have to have this angle because I know this side. So this is actually what I have to solve for first. In order to solve for this one, I probably have to know this one as well. Because that seems like the easiest way of doing that. What could I possibly use to solve for this angle down here on the bottom right?
The fact that it's 90 degrees.
The fact that it's 90 and there's a 9-degree tilt away from the sun. How do I know that's 90 degrees?
Because it's on the ground.
Because the sun coming straight down intersects level ground at a 90-degree angle. Good. So we're going to solve for this one first. And that one is going to be 90 minus 9 to equal 81 degrees. So bottom right angle is 81 using just subtraction. What then am I going to use to solve for this top angle here? Subtraction again. This time I'm going to do what minus what minus what?
180 minus 81 minus 60.
180 minus 64 minus 81. And when I do that subtraction, I'm going to be left with what? 35. So now I know all 3 angles on the inside of my triangle. I also have one complete angle side pair. And I have my unknown and its angle pair. So that means I can set up my law of sines ratios and work backwards to solve for my missing piece. So starting with my complete pair, I have sine of 35 degrees over 21 is equal to sine of 64 over x. And now I can just use algebraic manipulation to get x by itself, and I can plug it directly into the calculator. And we're going to go ahead and round to the nearest whole number.
It's also like a very colorful fish, really. You know, the one with the scales and all that.
Rainbow fish.
I feel like that's
Yeah.
more about like worlds than biology.
I would agree
You guys just don't know anything about
with
fish.
that.
I mean, you don't want to have a super smart child with no morals. That's
Yeah,
not
Right.
yeah.
Especially because
a
without
very good mixture.
Okay, so what do we get when we plug that into a calculator?
33 feet.
33 feet. You have to have that label on there. And then we are finished. How do we feel about law of science?
It's easy. Or,
Not terrible.
I don't know.
Okay, your homework is 5 questions, just like yesterday's, and it is technically due tomorrow.
we're
It's
technically
technically due tomorrow at
Midnight.